Good day, grade 7 learners. Welcome to our third quarter lesson in science, specifically on physics. Our topic for today is about distance and displacement. Our learning targets are differentiate distance from displacement and calculate distance and displacement covered by a body. Let us start with identifying the distance. Distance is the total length covered upon changing position. Take a look at this illustration. The body, starting from 0 meter, walks by 6 meters and goes back by 4 meters. The distance it covers is 10 meters. Let's move forward. To visualize the distance covered, illustrating the motion of a body is necessary. Having the reference point, suppose that a body moves 25 meters to the right, illustrated from point A to point B. Then, it moves 10 meters downward, moving from point B to point C. Lastly, it moves 25 meters to the left, moving from point C to point D at the final position. The total distance covered must be 60 meters. But how did we get 60 meters? The formula for distance is d is equal to d sub 1 plus d sub 2 plus d sub 3 and so on. In solving for the total distance, simply add the individual distances covered by the body. Substitute the given to our formula. We will have 25 meters plus 10 meters plus 25 meters, and the total distance will be 60 meters. On the other hand, displacement is the shortest distance from the reference point or starting point to the final position. It has direction. To visualize the displacement, marking a reference point is necessary. Suppose that a body moves 25 meters to the east, moving from point A to point B. Then it moves 10 meters south, moving from point B to point C. Lastly, it moves 25 meters to the west, moving from point C to point D at final position. The displacement must be 10 meters south. But how did we get 10 meters south? The formula for displacement is d sub x is equal to d sub 1 plus d sub 2 plus d sub 3, and this is the displacement along horizontal. For d sub y is equal to d sub 1 plus d sub 2 plus d sub 3 and so on, this is along vertical. The operations to be used in solving for the displacement is dependent on the direction where the body moves. The numerical coefficient is said to be positive if the body is directed to the right, north, or east. The numerical coefficient is said to be negative if the body is directed to the left, south, or west. Proceeding, let us solve for the displacement along the horizontal. Symbolized as d sub x, we will have the formula d sub 1 plus d sub 2 plus d sub 3. Substituting the values of the displacement along the horizontal dimension, we will have 25 meters east plus negative 25 meters going to the west. Why negative 25 in this part? The direction of the body goes west, therefore we will use negative in the numerical coefficient, and the integers with different signs shall subtract. Therefore, 25 meters east plus negative 25 meters, which is going to the west, is 0. the displacement along horizontal is 0. Let's now solve for the vertical displacement or d sub y. Using the formula d sub y equals d sub 1 plus d sub 2 plus d sub 3 and so on, the displacement along vertical is 10 meters south alone. Substituting the value, we will have negative 10 meters south for the vertical displacement. Negative 10 meters is the displacement along the vertical dimension. Therefore, the displacement of the body is negative 10 meters or 10 meters south. Now, let us check your understanding. Illustrate using the arrows the motion of the body and solve for the distance and displacement of the given below. A woman walks 2 meters north, 5 meters west, and 2 meters south. To illustrate, mark a reference for starting point. From there, draw an arrow 2 meters north. From the tip of the arrow of the 2 meters north, with another given, draw another arrow 5 meters west. From the tip of the arrow of the 5 meters west, draw another arrow 2 meters south. So this is now our final position. And the displacement is measured from the final point to the starting point. Now that we have illustrated the motion of the woman, let us solve for the total distance. The total distance is equal to d sub 1 plus d sub 2 plus d sub 3. Substituting the values in our given, we will have 2 meters plus 5 meters plus 2 meters. Disregarding the direction since that we are solving for distance. Therefore, adding this 3, the distance is equal to 9 meters. Moving forward, let us now solve for the displacement. The displacement along horizontal is determined by the formula d sub x equals d sub 1 plus d sub 2 plus d sub 3. Substituting the value, the only horizontal displacement is 5 meters west. Therefore, the displacement along the horizontal is 5 meters west. Moving forward with the vertical distance, we will use the formula d sub y equals d sub 1 plus d sub 2 plus d sub 3 and so on. Substituting the values, the displacements along vertical dimension are 2 meters north and 2 meters south. We will use negative 2 for 2 meters going to south. Therefore, adding 2 meters north plus 2 meters south, the displacement along the vertical dimension is 0. Therefore, in the given situation, the distance covered is 9 meters, while the displacement is 5 meters west. Good job in keeping up. As we end, let me share the same. Run when you can, walk if you have to, crawl if you must. Just never give up. By Dean Karnazes, an ultramarathon runner and an author. Thank you for watching. For more video lessons, follow the Facebook page and the YouTube channel of Exploring Physics. See you!